actually hits the little blue dudes. So we're gonna do the score goes up by 1. So we're gonna do score plus equals 1, and then we want to change the actual current score text or whatever the old score was. So let's do current and then capital score dot set then capital text and then open close and then put the string current score then plus score. So now the score's been incremented every time it gets hits. And next thing we want to do is make it so that this hammer doesn't just keep on racking up points every time it's over top. So let's do h.body dot check and then capital collision dot none equals true. In this predicament, the H actually represents the holes. If you go back up to where it says this dot physics dot add collider, you know the first parameter is player and the second is holes. So the P is for player and H is for holes when you go back down to the bottom. So we're going to do H dot body dot check collision dot none equals true. And after that's done, we want to go ahead and do a if else statement, but let's try using a try and catch, because like typically we don't use that, but we're gonna use that in this event, you know, like just in case we run to another error, something's still gonna run, you know. So let's do try and then let's make an object, and after that let's put an if else statement. Let's do if h dot y equals 295, h dot play splat, and then do dot y equals 295. So what's going to happen is going to play the animation but put his actual position to 295 once the animation is playing, and then we can actually make something happen when the animation is complete. So do h dot on then open close, and then the string is one word all lowercase. It say animation complete. After typing that in there, put a comma and then put function, and then something's going to happen once the animation is done. So we're going to do h dot set then texture open close and then string hold. So what set texture does is actually choose the actual I guess object or the frame or image, whatever you actually define, and plays that on top of whatever we just played. So say for example that the player was like a raccoon or something at first, and then we play the animation. The animation is going to overlap that raccoon and just play. So now the animation is no longer a raccoon. But if you do h.set texture and then pick an actual word, it's going to actually erase that raccoon and put the actual thing that you want there. So instead of having this little blue dude hopping out the hole, now we're going to actually put the hole right back there and get rid of him. So h.set texture and then hold. Next, do h.y equals 340. So now it's going to actually position them in the correct position. I know this seems like kind of weird, but after doing some you know, some tedious back and forth with this junk, I noticed that when you actually hit them, they get out of position and they're all positioned incorrectly. So this was my solution to fixing that. And then put like comma and then this. After that, for the else statement, do h.play splat and then dot y equals 230. So this is going to put the other holes in their correct position. So same thing, h.on and then animation complete, comma, and then function, and then h.set hole, well sorry, h.set texture and then string hole inside of that, and then h.y equals 275, and then do a comma, then a word this. After that, we could leave that, and then we could do a catch behind that. So for the catch, we're not going to put too much in there at all. We're just going to write the word error. So catch, and then the word error, open close inside of that, and then let's do an object and put a comment. Let's put the word nothing, so we know nothing's going to happen. We don't care about what happens after that. And now we need to actually position the holes, because remember, if we go back up to the create, we put this dot holes and then open close, you know, actually call the function, but we can't even position the holes if we haven't created it. So let's create the actual holes position. So holes 0, this should be an actual array. So holes array then 0.x equals 175. Then let's copy that, and instead of it being an x, let's put a y and then equals 275. After that, let's do holes and then 1.x equals 400. Then holes 1 dot y equals 275, and then let's do holes 2 dot x equals 600, and then let's do holes 2 dot y equals 275. So that's going to actually position the first 3 holes on top of the screen, so 0, 1, and 2. Now we need to do the last 3 at the bottom. So let's do holes, and then 3 dot x equals 175, then holes 3 dot y equals 340, and then holes 4 dot x equals 400, holes 4 dot y equals 340, holes 5 dot x equals 600, and then holes 5 dot y equals 340. So as you notice, some of these numbers actually match up and everything, because that's how typical Whac-A-Mole games are. Like if you look at it in real life, most of the holes are like, you know, kind of aligned perfectly, like perpendicular and, you know, diagonal and across and all that stuff. So outside of that, we want to actually change the depth of some of these holes. So like what I noticed is that when the character jump, he overlaps on, like, you know, the ones that's the more, you know, the lower portion of the screen, when they jump, they shouldn't be like getting jumped through by the ones that's on top of them. It doesn't look right at all. So in order to fix that, we need to change the actual depth on those squirrel things. So we're gonna do a for loop. So we're gonna do for, then variable g equals 3, and then we put the mark in and put g is less than 6, then g plus plus. So now we're going to say holes 3, 4, and 5 is going to be affected by this little for loop. So now we want to do holes, then array g dot depth equals 3. So now the actual holes depth are going to change now. So now that issue is gone. And then seeing that we coming real close to finishing this, the last thing we need to do is actually make these holes and everything, so they actually jump out where they're supposed to be and they actually go to the correct position. So like I was saying before, a function basically could take an input and run some code with it. You know, a function basically is a block of code that can be executed when it needs to be called. So we're gonna do g dot return the capital holes equals function, then open close, then write num. We're gonna use num for number, and then let's do holes and then array num dot body dot check collision. So capital collision dot none equals false. So what's gonna happen is that every single time that the add event thing goes off, it's gonna pick a random number, and then that random number is gonna be inputted into the return holes area. So it's trying to say whatever number comes through, do this exact same stuff to it. And then I'm gonna make it so that if nothing is there, jump out that hole. Other than that, just wait. So now we're gonna do an if else statement. It's gonna say if holes hop is less than 2 holes num dot play string jump dot y equals 295. So we're trying to match it up to the actual hole position that they're supposed to be in the first place, like we did up there with the hose. Then let's do hose and open close num dot on animation complete, and then put a comma, then function, and then we're gonna actually do something. So we're gonna do hose array number dot set the capital texture hose. So like I said before, it's gonna set it back to being just a blank little black hole, so it looked like he disappeared and fell in the hole. Then hose num dot y equals 340. Then hose num dot check collision capital, well, yeah, collision should be capitalized dot none equals true. So what it's saying is stop looking for this hole. You can't see the hole, stop trying to touch it. There's nothing there, so leave it alone. After that, let's end out with the comma and put this. Then we need to work on the else statement. So now else hose num dot play open close, then put the string jump in there dot y equals 230. And what that does, like I said before, is going to actually put them in the correct position that we set them to be in for the ones on the bottom. So hose num dot on animation complete for the string, and then comma function open close, then hose num dot set then capital texture holds again. So like I said before, it's looking for the one that was there before. It's looking for whatever we want to put there. We could have put the hammer to represent the actual hold position, but instead we wanted to be the actual hold itself, you know, not the little blue dudes, not the little blue curvy people. Now hold num dot y equals 275, then holds num dot body dot check collision, and collision should be capitalized, dot none equals true. So now I can't, you know, touch it no more. And then in that object, then put a comma and then this. After that, you know, you completed the whole return holds function. And now at that point, we just need to add something to this update area. That way, we can go ahead and finish the game off. So now we're gonna do, in the update, we're gonna do if hitting equals true and player dot angle is less than or equal to 80, player dot angle plus equals 20. So what that's saying is that once this angle is at a certain angle, you know, it's going to actually stop it from going past that. And only way that's going to actually happen when the pointer is actually down, because the hidden is equal to true and hidden is equal to false, because that's how we determine how we're going to activate the actual hammer. So now let's do the last part of the game, and that's going to be this else statement, else if. So else if hitting is equal to false and player dot angle is greater than or equal to 10, player dot angle minus equals 20. And there you have it. You got your whole game and everything. You might need to go to the bottom and turn the actual, you know, debug off. It might be on true, but you might want to set that to false. Outside of that, you know, we got one last game to be made, the little baseball game. I made a little, you know, something different about that game. It's not nothing but 100 lines of code compared to this one. If you notice, if you go all the way down, this game is probably about almost 300 lines of code, but the baseball game I created is about like 100. So if you guys are ready, let's go ahead to the next video, or I catch y'all when y'all ready. Take care.